One criticism I hear leveled against Bambu Labs is that if they break, it's game over. But is that true? Today, we'll get to work in a range of areas to find out. This video is pretty much 3D printing mythbusters, except the conclusion isn't so black and white. The question, are you doomed once something goes wrong on your Bambu Lab 3D printer? Can you get parts, and is it difficult to fit them if so? Let's dive in, and I should point out that this video is not a guide on how to do this maintenance or replacement, but instead a review of how hard the process is, especially compared to other 3D printers. First things first, let's be clear, and we're not judging Bambu Lab's technical support here. And that's because I have no first-hand experience with it. The only time I've used it was when I had to get an A1 bed replacement like everyone else. Therefore, in this video, we're judging their online support, such as the how-to guides, their self-guided wiki articles, and of course their HMS error codes, which sometimes pop up on screen or in the app. And we're going to start with two components on the A1 series, one of which also applies to the A1 Mini. In case you've been living under a 3D printed rock, Bambu Lab's A1 had a complete recall due to an issue in a small amount of heated beds. This is not ideal, but I think their response was pretty good. My particular printer didn't show any signs of the defect, but even so, I elected to wait for the complete bed replacement, which should be interesting because this component was never really intended to be replaced by the user. So when this printer was originally designed, was it designed with disassembly in mind? For this swap, Bambu Lab have a dedicated wiki page. It's got safety warnings and then step-by-step instructions on the process, with these images being annotated with specific details. Furthermore, there's an embedded YouTube video showing all of the steps in sequence, which can really help some people. The only tool needed is the hex key that came with the printer, and the estimated time is half an hour to 45 minutes. Here's a quick summary of the steps involved. We remove 4 covers followed by 4 screws. The bed can then be placed to the side. We turn the machine over, unplug some connectors, including a USB-C connector that's bolted in place. Then there's 2 large plastic panels that need to come off the bottom of the printer. This gives full access to all of the wiring inside. We can now disconnect 4 wires related to the bed and feed the loom out the back of the printer. With the printer back on its correct side, we place the new bed, retaining it with those original 4 screws and covers. We then feed the new loom back through the printer's frame, and for me, this was the fiddliest part, before reattaching all of the wiring at the other end. Now's a good time to compare the old and the new to see the changes that have been made. With everything reconnected, we can start to reassemble the bottom of the machine. And as you might expect, you're just repeating the same steps as earlier in reverse order. The only thing I'll point out is that it's vital to make sure the bed cable is installed with the least amount of twist, and your chosen orientation will be locked in place once you put on the rear lower cover. Here's everything back together, showing the path of the cable as the bed moves, and as far as I'm concerned, it's looking pretty good. We have a new addition in the form of this rubber bumper, and I expect the aim here is to prevent the cable from buckling sideways if the printer is tipped up on its end or pushed too hard into a wall. The final step is to double check that everything is working by warming the bed to 40 degrees and making sure it can reach and maintain that temperature. So how reasonable was this replacement process overall? I didn't use a stopwatch, but I'm pretty sure the time estimate was spot on, and the documentation provided was very thorough and easy to follow. Probably the worst element is that many people are going to have to deal with mains wiring. This should be fine as long as the printer is powered off and disconnected before you start, but it should be noted that for European customers, technically you're required to have your printer tested by a professional. In summary, for this job I would say it's quite reasonable considering that this was never planned by Bambu Lab. As for comparing to other machines, the best I can do is recall when I fitted a mains powered bed to an Ender 5. This is similar in that there's disassembly and then running wires back to the main board, but ultimately this took much longer because I was modifying rather than just changing, and there was additional hardware that needed to be fitted. A reasonable start, so how about item 2? When I reviewed the Bambu Lab A1, despite it having an identical print head to the A1 Mini, I found the part cooling performance not quite as good. The fan was also a little bit quieter than the A1 Mini, so I wondered whether I had gotten a partial dud. So a while ago, I went online and ordered myself a replacement fan. This is the same part for the A1 and A1 Mini, with a very reasonable price of $10 for both the fan as well as the shroud. Postage was quite fast, with the part arriving in a couple of days. And looking at this, I expected the job to be mega easy, with only 3 screws and 1 plug. But when I went to the instructions on the wiki, it seemed way more involved, with quite a lot of disassembly of the tool head. So how bad was it in practice? We start by removing the back cover and unscrewing the USB cable from the top. There's 3 screws to remove from the PCB inside, and once the board is free, we unplug all of the connectors. With some manipulation, this toolhead PCB can then be removed completely. However, there will still be a small ribbon cable attached that you should be careful not to damage. We now turn our attention to the front of the toolhead, where our next task is removing the quick release hot end. Unbelievably, we then have to remove a further 5 fasteners to take off the whole extruder. I chose to leave it resting in place and started to slide out the small portions that cover the cables. The instructions say to remove both sides, even though the cable for the part cooling fan only travels through the right hand side. Finally, we're up to the fan and there's 3 screws that hold it on, and we can see the reason for all of this disassembly is simply to create room for that cable to exit out the side. As you would expect, as we introduce a new fan, we're just completing the same steps in reverse. So we bolt it in place, route the cable up the side, and then start slotting everything back together, which is doable, but some of these steps are quite fiddly. We can then reassemble and bolt back the extruder, reinstall the tool board, starting with that little ribbon cable, and wrestle with putting it back in its place without catching any of the wires. With this done, I bolted it in and started to reinsert all of the plugs, but in my frustration I made a mistake, bolting the eddy current ring terminals to the wrong posts. 100% my fault, but when you're jumping through this many hoops for what should have been simple, you're increasing the risk of user error. I finished off by putting the last components back together and used the manual controls to verify that the new fan was spinning as it should. That was fine, but when I went to print, my mistake caught up with me. Fortunately, the printer displayed this error code and told me that the sensor should be broken. It was then that I pulled off the back cover and realized that I had bolted these terminals to the wrong place. A quick and easy fix. So what's my evaluation of this replacement? The guide said 20 minutes and I think I was pretty close to this, but overall it really frustrated me because there was too many steps for what should be a simple job, and that increased the risk of user error. On the positive side, the hardware management system did its job by pinpointing the problem and giving me an image that I could use to fix it. Overall for this, I would say needlessly complicated. Alternate cable management should have made this a 5-minute task. I've done fan changes and upgrades on many printers before. Typically, the worst part is that the wire goes all the way back to the main board, but we can solve this by adding DuPont connectors. But many printers today have dedicated toolboards, so all of the fan wiring only goes a short distance. The A1 and A1 Mini also have that. The problem is that the path for the cables is really fiddly, and that makes the job harder than it should be. With everything working, how about a quick torture test with this Dragon Scale fabric by F. Tobler? The large version of this is a 13-hour print that I started before leaving the printer unattended overnight, and the next morning I was pleased to return and find that the print completed very successfully. This design has lots of small parts touching the bed, and each scale has quite a sharp overhang on the underside. This is a very satisfying print to play with, so I've linked it below in case you'd like to try. That one really frustrated me, but there was better things to come. How about we move on to this abomination on the X1 carbon? And in case you couldn't see it, the hot end is no longer attached, pointing at this jaunty angle. Judging by the first layer being out of position, I'm guessing there was some sort of layer shift, leading to a catastrophic collision. Besides the hot end, we can see that there's damage to the part cooling fan duct, so that's the first thing that will change. For this piece, we need to buy the entire front housing that comes with this cover, the duct as well as the actual fan. There's also LEDs on the back of this PCB. The price for this is US $20. This one arrived the next business day, and bonus points from me for no plastic packaging. Comparing the old and the new, I hope the problem is clear. And making this change is a 30-second job. We simply unplug the old one, plug in the new, and it snaps to the front with its magnetic mounting. We can manually turn the part cooling fan on with the touchscreen to confirm that it's working. So let's sum up the X1 and P1 series fan replacement, and that's because the P1P and P1S is exactly the same, just with a different part and plug. Thanks to that magnetic cover, this takes a minute if that. I describe this as very fast and easy, and the only downside is there's no option to just buy the fan or cover by itself. If you just wanted to replace a worn out fan, you have to buy the rest too. But at least now I have a spare. In conclusion, this one is as simple as it gets. So let's fix this broken hot end. We actually have two options here, the cheapest being for $15, a replacement heatsink, nozzle and silicon sock, and this is the same for the X1 and P1. But on a catastrophic failure like mine where you want some confidence, you can buy the complete hot end, which includes the heater cartridge, the mister and cooling fan for $35 US. For the P1 series it's the same price, but there's different connectors. Once the magnetic cover is off, disassembly is really straightforward. We pull out the plugs, free the wires from the little holder, and then we undo two screws holding the heatsink to the bottom of the extruder. Once these are clear, the hot end simply pulls out the bottom. Again, when the two are side by side, I hope the reason for repair is quite clear. If we only wanted to change the hot end, it's still a pretty easy job. We have a metal clip which holds the thermistor and heater cartridge in place. We simply slide that off. We would then remove each of these from the old hot end and install them into the identical location on the new hot end, and you would use fresh heatsink compound, which I'm not doing here. We then slide back on the metal retaining clip, followed by reinstalling the silicon sock. After that, it's only 2 bolts to transfer over the fan and we're ready to go. But instead here, I'm going to use a complete hot end assembly that I ordered previously and had sitting ready to go. We slide it up from the bottom and reinsert those 2 retaining screws. We then plug everything back in and tuck in the wires behind their holder. The cover goes back on and we're done. For the P1P, it's the same, yet slightly easier, simply because the plugs are different and easier to connect and disconnect. As for that textured bed, after some time with this blade, I managed to get the surface flat so I could at least keep using the other side. Let's again sum up this procedure. Either version is going to take 5 to 10 minutes tops. It's fast and easy, and I like the way there's 2 options for different amounts of money. The only downside I see is the job gets messier if you're using new heatsink compound. Ultimately, this is in line with other convenient modern hot end swaps. So let's remind ourselves how it used to be with the E3D V6 standard. I do not miss at all trying to get the heater block on the angle I wanted and then doing a hot tighten. New age systems like this are so much easier. Finally, my patron Kevin asked me to cover some long-term and maintenance items. The first thing I want to cover is when the filament snaps, but it's still contained within the AMS tubes. On the AMS Lite, the fitting is easy to access. We push down and remove the tube. Hopefully then you can simply remove the piece of filament. If a piece is stuck in the middle, we need to release on the printer side, and the fitting is easy to see but a little bit harder to press because there's 4 of them close together. We can then run another piece of filament down the inside to push out the broken pieces. Not much to say apart from this one being super easy. Maybe the 4:1 splitter is a little bit trickier. Filament breakages here are straightforward in every scenario. For the regular AMS, we have a much more complicated system, and some fittings are easy to access, but if the breakage is contained within the AMS, well, we're going to have a much harder time. The first thing we'll need to do is remove all of our filaments, which doesn't seem like a big deal, but they do need to be loaded and prepared again later on. It's hard to see here, but there's actually a finger release for the main piece of tube coming out the back. We pull that down, and then the tube should release quite freely. But to get further inside, there's 2 screws we need to undo at the back, and that will allow the internals to lift up, but you need to be careful not to damage the attached wires on the bottom. Even with this access, it can be hard to get rid of the blockage on the inside, but I have always managed to struggle through and get it done. This one's definitely not as easy due to the complexity, and it can end up being quite a pain. On future versions, I hope Bambu Lab design it so the bottom flips open for easier access. Belt tension is pretty vital for a Core XY printer, and the system is quite novel on the X1 and P1 series. On the back, we have 2 sets of screws that we need to loosen, and by doing that, we release a spring-loaded section that holds the belt pulley. All we're meant to do from here is to move the gantry and print head through its full range of motion several times. The springs will do their thing, everything will settle, and we can turn the screws to clamp the mechanism back in the correct place. This system is pretty good. It's quite quick and easy to do because tension is automatically set. But what I will say against it is that to get the best results, further fine-tuning is needed. My patron Patrick released this set of tools for getting optimum belt tension, and you can see from his image that after tensioning there was still banding that his fine-tuning managed to eliminate. But on balance, I'd still say this is one of the more convenient Core XY belt tensioning systems around, especially when we compare it to some old school designs where you need to loosen a bolt, manually pull to the right tension and tighten that bolt again. That's a lot of trial and error to get the 2 belts even and the gantry square. In my opinion, apart from that A1 part cooling fan, this is a myth that has been debunked. There's a wide range of spares available for reasonable prices, and that's for all of the Bambu Lab machines, and a lot of time has been spent building up great resources on the wiki and other places. Just because Bambu Lab uses injection molded rather than 3D printed parts doesn't automatically mean they aren't designed for disassembly. Sometimes it goes the opposite way, with my old Prusa Mark III being a reliable workhorse, but I used to dread any work required around the tool head or electronics case. Let me know in the comments if you agree with the conclusion I've come to. Thank you so much for watching, and until next time, happy 3D printing. G'day, it's Michael again. If you liked the video, then please click like. If you want to see more content like this in future, click subscribe and make sure you click on the bell to receive every notification. If you really want to support the channel and see exclusive content, become a patron. Visit my Patreon page. See you next time.